properties of wave. Properties of waves. There are three properties of waves. Number one, reflection of waves. Number two, refraction of waves. Number three, diffraction of waves. So now we will discuss separately one by one. First of all, reflection of wave. When a wave is coming from some medium falls on another medium and bounce back into the same medium is called reflection of wave. As shown in figure. Suppose this is one medium which is like to be dense, and this is another medium. When a wave is coming from some medium and falls on this dense medium and bounce back into the same medium, this phenomena is called reflection of wave. This is incident wave and this is reflected wave. In this case, no change in wavelength and no change in the speed occurs, but only direction change, and this direction change causes the wave to come back in the same medium. Number two is refraction of wave. In this case, when a wave is coming from one medium falls on another medium and passes through it, with the changing in direction, is called refraction of wave is shown in figure. Suppose this is a boundary and when a wave, you can say this is another medium. When a wave is coming from one medium, this is another medium. Incident ray, incident wave, and this is refracted wave. When a wave is coming from one medium, falls on another medium and pass through it with the changing its direction. This changing in direction causes refraction, causes refracted wave. Why this happens? In this case, the reason is the changing in speed of wave due to changing in wavelength. So according to the universal wave equation, V is equal to F lambda. That is, V is proportional to lambda. Greater the wave, greater will be the speed. Smaller the wave, smaller will be the speed. So when this wave pass, which is coming from one medium, has some wavelength, when pass through another medium, so the wavelength change, the wavelength decrease, and this changing in wavelength causing changing in direction, because changing in speed occurs due to changing in wavelength. So this mathematical explanation show that as much the wavelength change, by decreasing, the speed will be also decrease. And when the speed decrease, the direction will be changed. The direction of the wave will be changed. In both cases, if the wavelength increase or decrease, the speed will increase or decrease, the direction of wavelength will be changed. So this changing in direction of the wave represent refraction of wave. So you must keep in mind, in refraction of wave, the wave direction must be changed due to change in the speed, and this speed change due to change in wavelength. The third one is diffraction of wave. This is a phenomena in which when waves when a wave is passes through the obstacle has small, hole the phenomena in which when a wave is passes through an obstacle has small hole, then the bending of wave take place. This bending of wave is called around the edge of small hole is called diffraction. Of wave is shown in figure. Suppose this is a obstacle having small hole, and these are the waves. These are the wave coming from some source. When passed through this small hole, then the bending take place around the edge of small hole. This bending of waves around the edge of small hole is called diffraction. So these are the three properties of waves, and you must keep in mind further. We will discuss the exercise, conceptual questions, and problems. So, if I come up to the conceptual questions, MCQs, you see the MCQs by yourself and check out your mind, check out your potential, how much you have the accuracy. Conceptual question, I just already explained that. Page number 25. Question number 1. Is every oscillatory motion simple harmonic motion? Give example. Yes, every oscillatory motion is simple harmonic motion because oscillation is periodic motion, and simple harmonic motion is that periodic motion which satisfy the equation A proportional to minus x. So mass attached with the spring shows simple harmonic motion. It is also represent oscillatory motion. Similarly, mass attached with the string, that is pendulum. Pendulum also shows simple harmonic motion, and because it satisfies the equations A proportional to minus x, as I discussed earlier. Question number 2. For a particle with simple harmonic motion, at what point of the motion does the velocity attain maximum at magnitude and minimum magnitude? So when a body has simple harmonic motion, so the velocity will be maximum at the mean point, and it will be minimum at the extreme point. Question number 3. Is the restoring force on the mass attached to the spring is simple harmonic motion? In simple harmonic motion, ever zero? If so, where? Restoring force, it can be zero. So the restoring force, if I do mathematically, we can show that restoring force on a mass attached to the spring is in simple harmonic motion ever zero. Suppose this is a mass attached with the spring. When we displaced from its mean position, this is the mean position. So this is the, let's say this is the amplitude. And this amplitude occurs due to the applied force. And this force stored in the spring in the form of restoring force. So the question is the restoring force on a mass attached to the spring is in simple harmonic motion ever zero? If so, where? So according to the mathematics, A proportional to minus x. This is the equation which shows simple harmonic motion. So according to Hooke's law, F is proportional to minus x. If displacement becomes zero, if the body come to its mean point, when a body is coming from extreme point to mean point, O is mean point, A is extreme point. So when a body is coming from A to O, at O, the displacement will become zero. When the displacement becomes zero, the force will be zero. So the restoring force might be zero if the body comes on the mean position. So this is the answer. If we shorten the string of the pendulum to half its original length, what is the effect on its time period and frequency? This is question number 4. If they shorten the string of the pendulum to half its original length, what will be the time period and frequency? So time period of the pendulum is so if L dash is equal to L by 2, when we convert this length into half, so what will happen? T dash is equal to 2 pi under root L dash divided by G. T dash is equal to 2 pi under root L by 2G, or T dash is equal to 1 over under root 2 pi under root L by G. This implies T dash is equal to 1 over 2 under root T. So the new time period will be decreased by under root 2 to the original time period. So when the length will decrease by 2, when the length become half, that time period will be also become less by the ratio of 1 over under root 2. And when the time period decrease, so what happened to the frequency? Since frequency is equal to inverse of time period, so F dash is equal to 1 over T dash. F dash is equal to 1 over under root 2 T. It means F dash is equal to under root 2. F dash is equal to under root 2 divided by T. This implies F dash is equal to under root 2 F. So if the length decrease by half, the frequency will be increased by under root 2 friction. So you have to done in the paper mathematically, not verbally, not theoretically, but you will do it in the same way. The other question is, suppose you are standing on a swinging instead of sitting. Suppose you are stand on a swing instead of sitting on it. Will your frequency of oscillation increase or decrease? So when you are sitting and you are standing, the changing in length, the changing in the, you can say, the length of the pendulum take place. And definitely when you are sitting, your length, your distance of center of gravity distance from the hanging point will be different than the standing position. So automatically the frequency will be changed. So in this case, when you are standing on the swing instead of sitting, will your frequency of the oscillation increase or decrease? The frequency of oscillation will be in this case, the frequency of oscillating body frequency of oscillation will be increased due to decrease in time period. Is per equation T is equal to 2 pi under root L by G. When you are standing in position, the length will be decrease. When the length decrease, the time period will be automatically decrease. When time period decrease, the frequency will be increased because F is inverse of the time period. So this is the mathematical proof.